Hello class, this is Dr. Mike. I want to give you a quick demo um, of the topic on Pandas. So we've been going through NumPy and Matplotlib, and probably the last package here of the big three is Pandas. And Pandas is about two items. It's about series and data frames. So first off, you can see here we want to import our packages. So I'll do Pandas as PD, and again, this is pretty common, but you can call this whatever you want. NumPy as NP and Matplotlib as PLT. Again, this is mostly the conventions you'll see, but there's nothing that says you can't call these X, Y, and Z. So just remember you can recall those as needed. So again, import is our command. We're going to import these packages. Now, Pandas is about two things. It's about a series and data frames. So a series, what is a series itself? It really is two arrays. One is automatically indexed and one is of the values. So it's almost like this. In fact, let's hide this column here. It's almost like a spreadsheet that has the series already indexed for us. So the demo shows us this. We have an index value of 0 to 4. So again, our indexing starts with 0, so I left this column here for you. And what we usually work with is the values. But again, in Pandas, series start at 0, as well all arrays do. But you can think of it almost like a spreadsheet, where we have column 2, column 3, column 4, column 5, column 6, and here's the values assigned to those columns. So how can we create a series? Well, pretty simple. You see here we actually, I'm going to have a series called S1, and we use the PD command. So PD, again, this comes from Pandas, right there. So PD, or Pandas dot, and it's uppercase S series. So that's an important note there. In this case, we're going to bring in these values like in this example, 12, minus 4, 88, and 9. And then we're just going to print them out. So you can see it actually shows us on the print statement. When we print it out, it shows us the array index value assigned to that variable. So again, 0 for 12 and 3 to 9. And these are integer 64s, are the data types. Now we can also create our own index though. It's almost like here where we can start with the default index. So unless we want to create an index called A, B, C, D, and E, we can create the same type of thing within Pandas. So you can see with the statement here, we went ahead and created S1 again, and we're doing the same series number. In this case, we're doing a key word argument of index equals, and we're actually going to pass in the actual index for those values. So let's run that, and you can see now we have A, B, and to D for those same values. Again, you can print the whole array, S1. So I've been doing print S1, but also you can just type in this case, the series name, just put S1, and it actually will dump it out the output. So either case works. Now let's say you just want to see just the values or just the index. Well, we can do that with the dot values. In this case, we get it says it's an array, and it's an array of these values. So we can print just the values out, or just the index. And actually, it's a data type of object in this case, because we have these index values there. Or we can do as an array with all elements. Or just by calling individual element. So what we did here is we called our series 1 element number 2. So 0, 1, 2. So remember, we're starting at 0 still. So even though this is A, B, and C, we can still call it by the element number. So it's almost the case here where we have our own elements, but there's still an index. There's still the index of 0, 1, 2, 3, and 4. still there within Pandas. So even though we can actually call it by either one now, we do have this index, and our index we called it. So there's always this available. So we called element number 3. Again, 0, 1, 2, 3, and then we have, sorry, 0, 2, 0, 1, 2. So we called element number 2, and we have 88. Or we actually can call by what we gave it the index of C. In this case, we said C for 88. In this case here. And we got, of course, we return back the element of 88. Now we can also select a range from 0 to 2. So 0, 1, and then we're going to end before 2. So it's actually 0 and 1. So we look at these range selections. It can be a little tricky sometimes. If I want to do the first two, I actually say go 0 to 3. So 0, 1, 2. So in any case, we can do range selections or index selections by individual items. Now a note here, let's run it real quick. You can see we're calling just B and C. There is a double quotation though for this one. Before we've been doing single brackets. Now we have a double bracket. So make sure you note that. And of course, we can actually write loops now. So we can go through, and let's say we want to test our data out. Now, of course, with only 4 elements here, we can see there's a negative number here. But as part of your data processing, you want to verify your data set and look for either bad values, inconsistent values, duplicates. And let's say in our case, we're dealing with measurements, and we have a negative measurement here. And this could come from an instrument error, it can come from processing errors. In case, we can actually loop through for I in S1, where I is less than or equal to 0, print I. So go through, loop through each one of these elements. And if it's less than or equal, if it's less than or equal to 0, print it out. So we can write loops for this. Now, again, we did this for here. It's a great way to look over our data. But as we get very large data sets, and we're talking you can have tens of hundreds of thousands of records, this for loop could take a while. So we can actually leverage Pandas to actually do the filtering for us and say, in S1, give me S1 that has less than 0. And we get back element number B. So actually get the element number, in this case name, as we assign to it, -4. And data type, it tells us data type as part of the output. This could actually be leveraged, again, for very large series as a way to check over our data. And on that, what we have is something called not a number, NaNs. When we deal with Pandas data structures, typically we deal with numeric numbers, but during processing issues, maybe a number comes across as a string, and so it gets tagged as not a number. So we're actually going to create a bad series here. So bad series equals a pd.series. Again, I'm going to call this bad series. And I can say, give me where it is null. I need to give me everything that is null within the series. In this case, it says number 3. So 0, 1, 2, 3. Let's go ahead and print bad series out so you can see it. Not bash. The whole thing out too. So there you go. So we can see element number 3 is not a number. And this can come from all kinds of issues. So again, part of your process of data analysis is going to be verifying your data set for any errors or inconsistencies. And this allows for that very easily. In fact, again, bad series, bracket, or bad series is dot is null. And there's options here, but we're going to skip those, close bracket. And you can see, again, take that out. We immediately identified variable number 3 as bad. So series themselves, we can do a math upon it. So let's say we have series 1 here. We can do series 1. Here's series 1. We can just do series 1 times 2, and we just do straight math on it. And before we were working with NumPy in a previous series we talked about, NumPy arrays, you can actually bring those in. In this case, we'll call it NPR, or NumPy array. And it's an existing array. We're going to just bring that straight in, and we get an array set up for that. There we go. So here we use NumPy to create an array. We bring that array in, and we shape it into a series within Pandas. So again, series are a great way of think of them as arrays with indexes. Let's move to the really powerful part of Pandas. That's the data frame. And this is a good a good thing you can see is the data frame itself is really a spreadsheet. Very similar to what we have here. I just recreated that. We still have an index that we can call with, but really we have now columns and items. And so this is what we mostly work with, is right here, the columns, column names, and the items within them. So again, so we can go ahead and create this with a key value pair. So this dictionary, this dictionary item here, run that, you see it. So before earlier on, we work with dictionaries, which has key value pairs like color and object and price. So we have color, red, green, blue, object, pen, marker, hat, and price of 1.25, 1.5, and 5.0. We actually bring that in and just say, you know what, this data element now, we're going to actually call it a data frame. So we use pd.dataframe, and please denote the camel case in there, uppercase D, uppercase F. And we're going to bring in that data element. And now we look at this. Now we have a nice data frame. So you can see these I was assigned to an index value, which is done automatically. We have the color, object, and the price. Now we say df.index. We can see where it starts and stops. It starts at 0. And it stops at 3 and steps by 1. So we can use the df command, because now with df being our data frame, we can actually work with this now. So df.index does that. Or we don't see the columns or the values. So we can sort of interrogate our data set, look at the different parts of it, or just see one column. In this case, we know we have a price column. Give me price, and then point out here, we can actually, you need to put this within quotes. There's a string, and we can pull this the column out. We can also do D1 sort values. We can sort by certain items. So in this case, we take the entire data frame and we sort it by price. So you see how we sort it by price, $1.25 to $5. We can also leverage Pandas to give us statistics. We can say just df1.mean, and we get just the mean price. Again, that's mean, so we need to understand our stats. There's, I believe, median, max, and min, so you can do all those. But best way, just do describe. df1.describe, again, this is our data frame. And you can call yours data1, frame1, foobar dot, in either case, it's the dot describe that's important. And there we go. We get a full range of statistics here. We get the count, the mean, standard, deviations, mins, max, percentiles. So, and if you're curious about help, this is a good time to point out the question mark there. So I'm curious about the describe. If I run this, I get this pop-up here in the bottom of my Jupyter notebook, and it gives me a little help file. Tell me about what it returns, what those mean, and so on. And it gives you some examples. I can close that. So again, if you're working with anything, most stuff within Jupyter Notebook will have a question mark you can add to it, and it should give you back help file. There we go. This is the property, and so on. So pretty handy. But more likely, you will be loading from an external source. Creating a few columns of data it can be handy. In this case, we want to have a little quick data set. But again, why not just go ahead and just create one within a spreadsheet? So in reality, you'll probably be creating some data. So in this case, I have a URL here. This is from GitHub. This is the Hubble data. So it's distance and recession velocity data here. And so I can actually use Pandas to read a CSV. So again, understanding our raw data is very important to our data process. In this case, this is a .csv. You can see right there in the URL. And this was local, that's fine too. I would download the file and I can import from a local disk. In this case, I'm gonna go straight to the URL and grab it though. So it's a CSV file. So I'm gonna do pd.read_CSV. Now there is a bunch of read functions. You can read Excel files, you can read it in tab delimited. There's a lot to the read statement. So again, the documentation for Pandas will be very, very helpful. So I'm gonna run that. If I do HT now, I can see that data has been brought in for me automatically. And again, we can actually start running some stats now. So I can start to get count means. And again, I'm not a astronomer by any means, except for the telescope I own. But this could be some research data, and we can go ahead and do our work here. Now, of course, we can do the deeper stuff here. We actually do correlation and covariance. We talked about this previously, or we will talk about it, what this means. So again, correlation being the biggest one. So we can do regression analysis upon this, or pick out specific items to do regression analysis upon. In this case, we want to correlate. Do we see a positive correlation between distance and recession velocity? And there's a strong 0.78 or 78% correlation velocity, or even just run a plot against this. I'll give you some optional stuff here. I'm going to move on here. So again, we're going to look at some actual live data. So here is machine learning repository. And we have both the data folder, data set descriptions, and so on. We have auto manufacturing. We have miles per gallon data by vehicle. So again, I'm going to create a variable called path to that same page. Again, I could download this. In this case, I'm going to leave it on the web. I'm going to actually do a pd.read CSV. Now, I just want to show you this more advanced work here is because there is some more stuff to do. We have some more keyword variables here. The delimiter we want to use. There's no header on there. Header being almost like the column headers. Look at this in the window. Look at this. There's no column headers. Those column headers are actually put into a different data. So there we go. There's the attributes for our column headers. Not uncommon to see it data stored this way. So again, this is the University of California, Irvine's data set for the machine learning. So what we do is a little copy and paste work, mile per gallon, cylinders, horsepower, and so on. I did this earlier as strings. I said the names equals, and I just did in the same order as we see here. So the last one being, I believe it's make, model, name. So I think it's not sure. We want to do NA values of a question mark. So we run this to go ahead and load the path variable with this URL. And we tell We're going to read CSV from path, which is that URL, and we have those options. So I run that. Now if I run MPG data, you can see I have imported that into a data frame. We have 398 rows and 9 columns. So very quick, very nice. I get information about my data set with the .info. So mpg data_data.info. So .info, apply that to your data frame, and you can get if it's a float, is it an integer, is it an object, hence being a text string. And you can get very advanced here now. We can actually start to do more correlation. Again, as we get further in the course, we're going to talk about statistical significance and correlations. In this case, does weight affect mile per gallon? And it does in our case. There's a negative correlation. Very strong, actually. So the idea being, if the vehicle weighs more, we get less miles per gallon. Now, we can probably guess that just by our own experience in life, but we need statistical significance, actual data to be ran to look at this. Now we can actually create a correlation. I'm going to copy that there. So I'm going to create a copy of just those 2 columns into my own data, my new data frame called miles per gallon to weight. So again, I call the miles per gallon data set. And with 2 starting brackets, I put the names of the columns I want in the brackets, and I do a dot copy. A nice way to peel data out from the original data set. I can take that for further analysis. In this case, we're going to do a scatter plot. And there you go. So you can see, the more the vehicle weighs, the less miles per gallon it gets. And the idea here is, if I communicate a negative 0.83 correlation between weight and miles per gallon, you might make sense. It might not. You might have to think about it and say, what does that mean? But if I show you a visual of that, that really hits the point home there. So, and again, we have a nice quick scatter plot, which I just created by doing a plot with scatter, weight, the data set, which we created, dot plot, dot scatter, with a quick XY, and that's it. Really great way. Within a few minutes here, I brought data in from an external source. I checked it out, and I actually did a correlation upon 2 of the variables and created a visual output that could be used for reporting. So Pandas, there's a lot there for it. It's a fantastic library, and you'll see it used everywhere. So hopefully this was a very helpful intro, and take care.